After a routine middleware update, every endpoint returned 504 gateway timeout. The middleware was returning a cached response without awaiting the actual root handler. Let's break down FastAPI middleware, logging, CORS, and custom middleware, how it works, and the exact mistake behind that failure. Middleware sits in the request-response pipeline, intercepting every HTTP call before it reaches your root handlers. Think of it as security checkpoints at an airport. Every request passes through them on the way in and out. CORS middleware in FastAPI intercepts every incoming request before it reaches your root handler and adds the necessary CORS headers. It's essential when your front end lives on a different domain, port, or protocol. Here's a typical CORS setup. We list specific trusted origins, enable credentials, and whitelist methods and headers. Never use a wildcard with credentials. The browser will reject it. Custom middleware uses the call next pattern. You run code before the request reaches your root and after the response is generated. This is perfect for performance logging and injecting request IDs. This middleware logs every request with a unique trace ID and processing time. Notice we await call next to get the actual response. Missing that await is a common bug. FastAPI middleware follows the onion model. The last middleware you add is the outermost layer. It processes requests first and responses last. This order matters for header injection and short-circuiting. Here, CORS middleware is added first, then security headers, then logging middleware. Request order, logging security CORS root. Response order, root CORS security logging. Sometimes you want to block a request early. By returning a response directly without calling call next, you short-circuit the chain. But be careful, inner middleware like CORS won't run, so you must add headers manually or place CORS outermost. This middleware blocks requests from known bad IPs. It short-circuits by returning a 403 response. But if CORS middleware is inner, the 403 won't have CORS headers. The browser will show a CORS error instead. You can catch exceptions globally by wrapping call next in a try except block. This ensures every error returns a consistent JSON response with a trace ID for debugging. This middleware catches any exception, logs the full traceback, and returns a 500 with a generic message. But don't swallow HTTPException. Let FastAPI's exception handlers deal with those. This is the same issue we highlighted at the start. Here's exactly why that happened. The new middleware called call next but didn't await it. The coroutine was never executed, so the root handler never ran. The middleware returned a placeholder response, but the actual request timed out waiting for the real response. When you need to allow origins dynamically, e.g., multi-tenant SaaS, pass a callable to allow origins. This function receives the origin and returns true if allowed. It runs per request and can check a database or config. If an earlier middleware returns an error, e.g., 401, before CORS middleware runs, the browser sees a CORS error instead of the actual status. Always add CORS middleware as the outermost layer, first in add middleware calls, to ensure CORS headers are present on every response, including errors. Use curl-x options to verify CORS pre-flight responses. This isolates browser caching issues and confirms the server returns correct headers before debugging front-end code. A middleware returned a cached response before awaiting call next, causing every endpoint to hang indefinitely because the root handler never executed. The fix is simple: always await call next and assign its result. Then modify the response as needed. We also added logging right after call next to confirm execution. This prevents silent failures and makes debugging easier. If you don't await call next, the root handler never runs. The middleware returns a placeholder response, and the actual response is lost. This is exactly what caused our 504 incident. This is the exact code that caused the production incident. The missing await meant the root handler never ran. Always use a linter to catch missing awaits. The CORS spec forbids wildcard origins when credentials are true. FastAPI raises a value error at startup. Always use explicit origins in production. If you add IP blocker after CORS in code, it runs before CORS on the request. When it short circuits, CORS never runs, so the error response has no CORS headers. Always add mandatory middleware like CORS first. If you catch all exceptions, you'll turn FastAPI's proper 404 or 422 responses into generic 500s. Check the exception type and re-raise HTTPException after logging. To debug middleware issues, test CORS with curl, add a timeout middleware to catch blocking, and log entry exit of each middleware. A health endpoint that bypasses all custom middleware can help isolate problems. Let's run through some common interview questions. Describe middleware execution order, LIFO for request, FIFO for response, onion model. Why is wildcard with credentials a security risk? Browsers reject it. Spec requires explicit origin. How to short-circuit middleware? Return response without calling call next. And a few frequently asked questions. What's the difference between middleware and dependencies? Middleware runs before root matching, dependencies run after. Why do I get CORS errors in production but not locally? Check allow origins list, ensure no wildcard with credentials. Can I have too many middlewares? Each adds overhead, 20+ may increase latency. To wrap up, remember the onion model, avoid wildcard with credentials, always await call next, and test thoroughly. Middleware is powerful but requires careful ordering and testing. Ready to go deeper? Up next, FastAPI testing with PyTest and Test Client, then FastAPI WebSockets, then FastAPI deployment. Find them all at TheCodeForge.io. Thanks for watching. The full article and code examples are covered in detail at TheCodeForge.io.